Hi there, I'm David Tabb, a professor over at Stellenbosch University, and today I'm going to demonstrate how to do two basic functions for visualizing data using three different programs: Microsoft Excel, GraphPad Prism, and the R statistical environment. We're going to start with Excel because I think this is probably the environment that most people are familiar with. I will be using, for my examples, Excel 2016. However, whichever version you have will probably do much of this just the same as it would appear here. Now, you should have two files that you downloaded from a Google Drive or were distributed in class. And we're going to start with the one called Distribution from February 19th. So if you are able to copy that file to Excel, probably the simplest way to do this is simply to drag the distribution file over to a blank Excel window. And as you can see, it opens up just fine. We could also open this file using the File Open dialog, but we would have some questions that we don't really care about at the moment. So let's just use the simple model. Now you'll see that I have a whole pile of numbers here. This is a pre-baked example, and if I hit end and down, I can skip all the way to the bottom of the list. I have 400 numbers here, and what I want to see is how they stack up. How do they distribute across their space? So one of the simplest things that I might want to know would be what is my range? What is the minimum and maximum value for this collection? So I'm going to pop over to column C here, and I'm going to enter a formula. I'm just going to pop it right up here in the formula bar. I'm going to say equals min A1 through A400. So you may have remembered from just a moment ago that we had 400 values appearing in column A, and this minimum function is going to tell us the smallest of all of them. Now, it's specifying this range of A1 through A400. I'm going to further specify that I want exactly that range even if I move this formula to another place. That's what those dollar signs mean. Always look at 1 to 400. Don't readjust these values. So I see that my smallest value out of that entire collection is negative 0.9. Now I'm going to copy that formula one down. You can see that the formula is exactly the same between those two. But in the case of the second one, I'm going to change the formula so it reads maximum. Okay, so now I know that the distribution of that the range of my data runs from negative 0.9 to positive 7.46. So one of the first things I'm going to have to specify to create a histogram from these data, the whole point of this exercise, is to pick a series of bin widths that's going to make sense. So I'm going to specify that the values from negative 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8 will be the boundaries between these bins. Now the next step that I need to do is kind of complex. You may have entered formulas like these for minimum and maximum, as you can see on screen there. But now we're going to enter a special kind of formula called an array formula. And an array formula is one formula that takes multiple ranges as an input and outputs a whole set of values. So we're going to highlight all of these values to the right of the bin widths, the bin boundaries that we set before. And now I'm going to click the f of x function, the insert function capability. So we're going to use a function called frequency. And if you simply type in frequency in the dialog, it should find the frequency function, as well as some others that relate to it. So we're going to specify frequency and hit OK. Now it needs to be told where it's getting its data from. What are the values that it's evaluating frequencies for? And again, we're going to specify that we want values from A1 all the way down through A400. I held down Shift and then hit End down in order to go to the last item consecutively downward. That's all fine. So now it's specified those 400 values. And now for the bin array, we are going to specify those bin boundaries that we had up here. And if I scoot this out of the way, you can see that those are going to be E1 down through E10. And I hit this. Now, I need to enter this formula across all of those boundaries. I hit OK, and something's gone wrong. There we have it. So this is one of these key differences that we experience in array formulas that we don't typically see. We see that the top item in our output array, squares, received the formula, but these others did not. That's clearly a problem. So now I'm going to copy this formula. We got it in a nice formulation now. I'm going to copy that whole formula. But this time, I'm going to highlight all of those squares. I'm going to specify the formula up here, all in place. This time, however, I'm going to hold down Shift and Control and hit Enter. Now we've applied that one array formula to have this entire output array. It's a very strange feature in Microsoft Excel, and a lot of people don't really know how to use it, so they find it very difficult to get histograms in place. So holding down Control and Shift when we hit Enter applied that one formula to use that entire array as a place to output the formula's results. So what we see is that although we had a lowest value of -0.9, we see that our first bin is 0. And this is one of the things we should be thinking about in frequencies. In the frequencies, it's showing anything up to -1. Because that was lower than our first value, there's nothing there. There were only 3 values that were below 0 but greater than -1. There were 21 values that were less than 1 but greater than 0, etc. So you can see that we have frequencies here, and really the only thing left for us now is to plot those data. So I'm going to grab out F2 through F10, choose to insert a visualization. I choose the first bar graph type. I like bar graphs, they're easy. And here we see that we have our frequencies shown visually. But the legend or the values that were shown in the x-axis, however, are not correct because they're showing the first value, the second value, the third value, and instead what we want to show are the actual bin boundaries. So I'm going to right-click on the panel here and go to Select Data. I come back in here to horizontal category or axis labels, and I see I've just got constants in here at the moment, 1, 2, 3. I'm going to edit that instead to select these labels that correspond to those frequencies. And now we see that the labels at the bottom of our graph correspond to the frequencies that apply to them. So one of the things that you can do with a histogram is evaluate, for example, whether the data appear normal. For a normal distribution, we like the data to be nice and high in the middle and to have a nice tight deviation around there. So if we were to look between boundaries that were symmetrical around the center, we would have a certain amount of data accounted for, 68%, if you were looking plus or minus 1 standard deviation and so on. And as we scoot further and further out, we see an increasing fall off. Now in this case, we have data that are what we call a bimodal distribution. And the simplest way to remember that is that it's got 2 humps. We have a hump over here in the data between 2 and 3, and a hump over here in the data between 5 and 6. And those 2 distributions are kind of overlaid on each other. So this histogram allows us to see how the data are distributed, and from that we can decide certain kinds of statistical tests that would or would not be appropriate for dealing with it. Okay, now I'm going to show you in just a moment how to do this in another way, this time using an analysis package that's included within most recent versions of Excel. Hi everyone, I'm back. This time, let's recreate the histogram using the analysis toolkit that's included in most recent versions of Excel. Once again, we're going to drag our input file, the distribution, onto a blank version of Excel, as we see. Now we have our 400 values appearing here. But we're going to need to add in some more information before it can create this histogram. As you may recall, last time we found that our smallest value was somewhere between -1 and 0. So again, we're going to enter -1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. -1 is smaller than our lowest value. 8 is larger than our largest value. Now, in order to use these kits, we need to have them activated. If I click on my data page, I see that there's no analysis toolkit in place already. So if I pop over to the File menu and drop all the way down to the very bottom, the Options menu, I should get a dialog popping up that looks like this. There are a lot of capable features in here that we can consider, but at the moment the one we care about is add-ins. And you see that even though no toolkits, no add-ins are currently active on this computer, we do have some that have been installed, like the Analysis Toolpak. So we want to manage our collection of add-ins. Down here at the bottom we see Manage Excel Add-ins Go. Click on the Go button. You should see 4 different toolkits that you can activate at this point. The one that I want to activate is the Analysis Toolpak. I check that one and then I hit OK. And now on my data page, I see that data analysis has shown up. So let's click on data analysis, and we should get a dialog box that makes it a little easier to navigate this process. We see that a wide variety of options are available to us, things like Fourier analysis and so on, but the one we care about today is histogram. So click on histogram, click OK, and you should be into the software. This should remind you of what we saw when we were entering a formula using the formula wizard in Excel. We again have to provide our input ranges, and we must specify the boundaries of the bins that we're going to use. So let's start by specifying our input range. Now we've already established that's A1 through A400. Remember that there are 400 rows in column A. This bin range is one that we just entered on screen in column C. So we're going to specify that we want row 1 of C down through C10. Okay. Next, we're going to specify where the software can output its information. So we're going to use an output range, and we'll simply dump all of that result into E1 over here. So outside the range of all the information that we've given it as an input. And we're going to specify that we want not only a table of frequencies, but we also want a visualization of those data in a bar chart. With that, we hit OK, and up pops our data. So we can see that the bin boundaries are here. Remember, when we did this in the frequency function a moment ago, we realized that none of the data were less than -1. That value is going to get a frequency of 0. These 3 values that we see here are those that range between -1 and 0. And down here at the very bottom, we see that this function is also giving us a little bonus. It's telling us, are any of the values in your input data higher than the highest bin boundary you gave us? And in this case, it's not. We knew that the highest value was between 7 and 8, so no problem there. And then, of course, we have the visualization that's been helpfully shown. Now we have axes on that have been labeled in our graph to show that the height of a bar in a histogram represents its frequency. And the bin labels have been shown across the bottom. So as you can see, that's a much more straightforward way of generating these plots. And yet, there's a little bit less flexibility around it in that if you don't want the graph to be labeled in particularly this way, you've got to change all those things after the fact. So one way is a very manual way to enter the formulas. In the other case, the data analysis toolkit does a lot of this manipulation for you. It remembers that the frequency function is the one that you need in order to compute these bar heights that we have in a histogram. Okay, with the next part of this exercise, we will move on to a bar plot and whisker plot. This is a rather more difficult kind of visualization, and this time the data analysis toolkit does not have a lot to offer us. So bear with me, and we will soon have that on screen. Hi there. For the last part of the Excel demo, we are going to create a box plot with whiskers to represent the quartiles of 2 different distributions to compare them to each other. Instead of using the distribution file, which we used for the examples of histograms, we're going to use the A versus B file instead. So I'm going to drag that into an Excel, and I should have my data coming in. Now before, we had 800 rows of data, 400 rows of data because we had 400 points. In this case, however, we have only 80. And we see that the points have been separated in their labels between the B set and the A set right here. Now, I'm going to create an extra column space in between the intensity values and their labels. And now I'm going to move all of these B data from their current location to be beside the A values. So this will become my A column, this will become my B column, and these labels will simply go away. And at the end, you should have the same number of A values as you do B values. Great. So now we have our data in a new format that makes it a little easier to work with. We are going to use the quartile function to figure out some distributional characteristics of these data, and we're going to give it 5 different arguments. Oops, sorry. Just 0 through 4. 0 is the minimum, the smallest value seen. 4 is the maximum. 2 is the median, the middle value in the series. And the first and third are the 25th and 75th percentiles. Now we need to have an A and a B column, and we're going to specify we want to grab the quartile from A between row 2 and row 41, which is the last one. And we're going to have it look at column D, row 2. Now you'll notice I have some dollar signs in here. Those lock those values into place. Even if I copy this formula to another location, it will still be forced to look at the area between row 2 and row 41 in whatever column that is. The column isn't locked there. In the second case, I've told it to lock down column D as the source of which quartile it's coming from. And the reason we do that is that I'm going to copy this formula to all 10 of these locations. So the smallest value we have in column A is negative 0.02. Our lowest value in column B is 1.09. Okay, so these are maximum values, these are minimum values. These are the medians. However, we need differences in order to do the little trick we're going to do with our box plot. So I'm going to grab out these same values in the first row. I'm going to just keep E2 as it is and F2 as it is as well. But these others are going to be differences between a value in column E and the one above it. So our first difference will be between the lowest value, the minimum, and the second value. And then we're going to copy that to all of these other locations. So you can see that this should be the difference between the maximum value in column A and the 75th percentile. That's great. Now we're all set to do our visualization. So let's grab these data and insert a stacked column plot. That's the second one in the dialog. Second row, first row, second item. And I'm going to grab it from where it's pasting it at the moment and shove that over here instead. Okay. So the first thing you should notice is that this stacked column chart looks completely wrong. Why does it have 5 bars? We only have 2 groups. And the reason here is that the software has misunderstood that rows and columns are opposite orientation for us. By right-clicking on it and selecting data, we can correct this problem. I can switch row and column by clicking this, and suddenly we'll have something that makes a lot more sense. Remember that the highest value we saw for column A was 4.4, and we see that our bar for A now maxes out at that. The highest value we had for column B maxed out at 7.1, and here we see that its highest value is just over 7. So we're in a very good place to start. So now we need to get rid of some of the information here. You can keep in mind that your median for these two values should be at 1.85 and 3.95, which tells you that this boundary between silver and yellow is the median. The only 2 boxes we actually want to appear here are the silver and gray boxes. So for each of these other series, I'm going to change it so that I get no fill and no outline. Okay, that got rid of our top one. We're going to get rid of this one as well. Again, no fill and no outline. And finally, we have these values. There's going to be nothing that appears in this space. So these are going to again be selected to be no fill, no outline. And you might say to yourself, well, that looks an awful lot like a box plot. And you'd be right. What we have is a visualization showing the median, the 25th percentile, and the 75th percentile for both A and B. We're almost there. But we mentioned that we were going to do a box plot that includes the full range. So we're going to add whiskers that represent the extent of getting to the maximum value for each distribution and the minimum value. So we have to specify first off, what are we adding relative to? And we are going to add bars that extend in the positive direction upwards from the gold bars here. So let us add a new feature to this graph, a new chart element. We're going to add an error bar, and I'm going to specify that I want more options. Remember, we are adding a bar extending up to the maximum. For the vertical error bar, we're going to specify that we only want one that extends in the positive direction. And then if we roll to the bottom, we can provide what amounts should be added to each of those bars. I'm going to specify custom and specify value. Now I need to specify a positive error value. And remember, this is the part extending from the top of the 75th percentile to the maximum, which is the last row of our differences. And now we say OK. Grand. So that's good for the maximum values. You can double check it. We said before our maximum for A was 4.4, and yes, this whisker extends up to 4.4. Our maximum value for B was 7.1. We see that we're right about there, so that's good news. Now we need to add, with respect to this lower bar, the gray bar, a negative pointing whisker. So I select the silver series there and click Add a Chart Element. Again, I'm going to add an error bar and use more options again. With this, I can add a minus bar because we only care about the one going in the negative direction. And we see that the software is adding a minus direction, but it's doing so with respect to the wrong bar. See that? It's adding it to this gold bar. And that's not acceptable. So we're going to remove this element and try again. How about we try clicking the area beneath the silver bar? That's kind of tricky, isn't it? The bar is not shown here, but we're going to be adding a bar to its top, in essence. Okay, so we'll add a graph element, error bars. Oop, not all error bars, that's silly. We're going to add a more options error bar. It points only in the negative direction. We see here that it's extending out of the bottom of the silver, which is good. And we're going to supply a custom value for that. And remember that this is a negative bar. It is representing the distance from the 25th percentile to the minimum, which is shown right here. Isn't it? No, I've botched this. Oh, yes, that's correct. Okay. So here we've got a value that should extend now. And it's vexing me. Again, we're going to specify a negative value. Oh, it's being awful to me. I'm not sure why, but it is. All right. Now we're going to add the value from the lowest value to the 25th percentile. Okay, so did it work? Our lowest value that we saw was negative 0.02 for A. Does our whisker point that far? It does. It hits right to the 0 line, which is close enough. Here in column B, we saw that our lowest value was 1.09, and if we look, we see that this whisker points to almost exactly the right spot. So that's it. We have now created a box plot showing the median, 25th percentile, 75th percentile, minimum, and maximum for two different distributions. The only other thing I would point out is that you probably don't want to keep your legend on screen, so you can click on that and hit delete for it to just vanish. And now you have a nice, clean box plot with whiskers. Box plot with whiskers. Thank you very much.